Welcome to HPC News Bytes, a weekly show about important news in the world of supercomputing, AI, and other advanced technologies.
Hi, everyone. Welcome to HPC News Bytes. I'm Doug Black of Inside HPC, and with me is Shaheen Khan of RIKEN.next. We're going to start off with quite a bit of quantum news. We're seeing more news and greater claims by the quantum computing industry, touting their roadmaps, projected or achieved performance metrics, and mergers and acquisitions. In recent weeks, Quantinuum, IBM, IonQ, Rigetti, D-Wave, IQM, Microsoft, and others have made big announcements. IBM launched an updated roadmap, putting stakes in the ground. The company said it has a, quote, clear, rigorous, comprehensive framework for realizing a large-scale, fault-tolerant quantum computer by 2029. That's a pretty bold statement, Shaheen. I suggest we put reminders in our calendars for 4 years from now so we can hold IBM accountable for what they said. IBM and RIKEN published a paper on results of a quantum chemistry application run on a hybrid system comprised of Fugaku and IBM Quantum. IonQ announced a series of acquisitions to beef up its offerings and roadmap. The quantum industry is crowded, so a consolidation wave is really not surprising. IonQ and Kipu Quantum announced the successful solution of, quote, the most complex known protein folding problem using Kipu's algorithmic framework and IonQ's quantum hardware. Quantinuum announced a record for quantum volume and said it has achieved its 5-year goal of 10x annual QV increases. They also set a new record by creating a 32-qubit entangled state with high fidelity. We talked about D-Wave's Advantage 2 system recently. They talked about quantum advantage on a problem that looked pretty real. IBM, Microsoft, Google, Q-Era, and others talked about breakthroughs in quantum error correction. So, Shaheen, what do you make of all this?
Well, my short answer continues to be the same as before. The industry is making great progress, but it's far from a, quote, transistor moment or quantum advantage for an important application. So it has a lot more progress to make. As for IBM, I think I'll take you up on that suggestion, Doug. They have a pretty good record of executing on their roadmap, and the plans were delivered with confidence. But delivering a real programmable, fault-tolerant quantum computer with 200 logical qubits and capable of 100 million quantum gates that can provide quantum advantage for a real-looking application and do all of that in 2029, that is pretty ambitious, even as we cheer them on and hope they hit it out of the ballpark. IBM has been talking about logical qubits and quantum gates, and if it's really fault-tolerant, then coherence times are also covered. But those numbers don't say enough about circuit size and circuit depth, which imply what applications you could run. So we should cover the metrics that are typical in the industry. Those include random circuit sampling, RCS, is an artificial test that is especially hard for classical systems to do, but verifies that the quantum computer can do what is expected of it, to run random circuits. It's what was used to claim quantum advantage. Randomized benchmarking aims for a rigorous quantitative assessment of gate fidelity by checking the quality of quantum operations. Quantum volume, which was introduced by IBM and adopted by the industry, especially by the trapped ion vendors like Quantinuum, it's a measure of overall computational performance based on number of qubits, connectivity among those qubits, error rates, and coherence times. Algorithmic qubit, used especially by IonQ, quantifies the usable size of a quantum computer. It's an analog of quantum volume. Circuit layer operations per second, CLOPS, also introduced by IBM, measures how many layers of gates a system can execute per second, indicating processing speed. Most of these are good approaches to characterize a system and a necessary step before you go up the ladder to run small kernels and go up from there to more substantial code. Another good way to track these is the DiVincenzo criteria. These were proposed by physicist David DiVincenzo in 2000 and is a set of 7 conditions that make a system eligible to be a quantum computer. They include scalability, initialization, long coherence times, universal gates, qubit measurement, and interconversion or transmission of qubits. Achieving all of them simultaneously is the big challenge, especially scalability. These criteria can also provide a framework for evaluating hardware performance.
Fujitsu said it has won the contract to design Japan's next-gen supercomputer to succeed their Fugaku system, which entered the top 500 list in 2020 and remained the world's #1 supercomputer until the Frontier exascale system displaced it in 2022. Fugaku is still on the list at number 7. According to an article in the Register, the successor, provisionally called Fugaku.next, is expected to be another ARM-based system using a CPU derived from the upcoming Fujitsu Monaca data center silicon. Shaheen, several times I've heard you express admiration for the Fugaku system. What is it about the architecture you like so much?
Well, right, I do. And what I like about it is its ability to run really difficult problems very fast, not just the easy problems. So according to the news, Japan's steering committee for supercomputing has chosen RIKEN to lead the overall project and assemble the coalition of players that are going to develop Japan's next generation flagship supercomputer. And just like last time, RIKEN and Fujitsu will cooperate to build this. We covered the chip that will be used in this system last time. It's focused on performance and energy efficiency for a wide range of applications, including AI. For the CPU itself, they projected very nice performance targets for LLMs, for example, and other AI applications. But they also expect to have the ability to use AMD GPUs for seriously high-density computational needs. So yes, I am pretty excited to see this and look forward to learning more. All right, that's it for this episode. Thank you all for being with us.
HPC News Bytes is a production of Orion X in association with Inside HPC. Shaheen Khan and Doug Black host the show. Every episode is featured on InsideHPC.com and posted on OrionX.net. Thank you for listening.